All right, so last thing here. Last week we spent all week just breaking down how to graph rational equations, rational graphs. So we looked at our zeros, our holes, our vertical asymptotes, our horizontal asymptotes, and all of that stuff, right? So we got how to do it. If you got questions about that, please let me know. I'll be glad to go back over it with you before Wednesday. All we're adding on to it today is writing intervals of increase and decrease, and also your end behavior. So nothing has changed in that aspect since we did it from polynomials. It's still the same. Remember your end behavior. Oh, wrong button. So still remember your end behavior. As x approaches negative infinity, your f of x is going to approach something. As x approaches positive infinity, your f of x is going to approach something. So that was our end behavior that we had. Please write that back down. So you've got it. Now, the nice thing for this, with rational graphs, the end behavior always approaches your horizontal asymptote, which is very nice. If there is no horizontal asymptote, then it's just going to be a special graph, so you have to look at it specially. But when we do have a horizontal asymptote, your end behavior is always going to approach your horizontal asymptote in both directions. It's very nice and helpful that way. So we got as x approaches negative infinity, your f of x is going to approach your horizontal asymptote. Then as x approaches positive infinity, your f of x is going to approach the horizontal asymptote on the right side. So that is what we got there. So if you're looking here, we've covered almost everything we need to know. I already talked about that. So the easiest to find at the graph, the easiest to find by looking at the graph, these are, can't read, sorry. The key for these is to remember the notation. I wrote the end behavior above, and we're looking at that. So helpful hints, draw your asymptotes. The leftmost and rightmost graph are going to approach your horizontal asymptote. Remember, that is your end behavior by definition, what's going on at the left and what's going on at the right. And then check between the holes of your the holes and your vertical asymptotes to determine your increase and decrease. So that's kind of what we're looking at here. So looking at a few of these, and then I'll turn you loose. So state the intervals of end behavior, and we're good to go. So here, if I'm looking at my asymptotes, that's going to be y equals 0 as my horizontal asymptote. It approaches that but never crosses it. I have a vertical asymptote at 2. And I also have a hole at 4. Just kind of labeling some things. So you got a horizontal asymptote at y equals 0, vertical asymptote at x equals 2, and you got a hole at x is equal to 4. So if we started this graph from the beginning, you would already have all that listed, right? So nothing new. We're just picking out of a graph. So here, if I'm looking at my graph, my intervals, so I got increase and I got decrease. So if I'm following along this piece right here, is it going up or is it going down? It's going down this whole time, right? So this left side, it's going to go from negative infinity. How's it going? Because I'm just looking at the x values, and then it's going to approach the vertical asymptote, which is 2. So it's going to decrease all the way from negative infinity all the way to positive 2. Then it jumps and goes up here. And what's it doing here? Is it increasing or decreasing again? It's decreasing the whole time, right? So in this case, I'm not going to have any increasing. I don't know why I put it on increasing. That's my bad. So it's going to decrease. We already wrote negative infinity to 2. That's my bad. Then it's going to pick back up at 2 from the top and go down to 4. It's going to pick up at 4 and go to infinity. So the difference in this is that it's not going to be equal to 4. That's why it's open parentheses. So it's on each side of 4. So it comes super, super close to it, but never touches it because 4 is a whole. Same thing with 2. That's why we're using parentheses instead of brackets. It approaches it, but never actually touches it. So that is why we're going to use parentheses. Good morning. Instead of brackets. Okay. So intervals are going to look at your asymptotes mainly. Now, in behavior, always approaches the horizontal asymptote. So as x approaches negative infinity, my f of x or my function's going to approach 0. And as x approaches positive infinity, my function's going to approach 0 here as well. So you're looking here. Where's the graph going? It's getting closer and closer. As I go to the left, what's happening on this end? It's getting closer and closer to 0, but we'll never cross it. Same thing over here. As I go to the right, it's getting closer and closer to 0, but we'll never cross it. So that's why my end behavior is it's approaching 0. So remember, as x approaches negative infinity, that's just a fancy way of saying left side of your graph, it's going to approach, y is going to approach 0 because f of x is y. Same thing. It's just notation. So what's going on at the end? Cool. Stuff we've seen. So now let's look at this one. So if I'm looking at my asymptotes, I got one here. I got one here. And it looks like it's here maybe. I don't know. It might be up there at 1. I can't tell. We'll call it 0 for now. That's okay. I think it is 1, but I'll make it right. That's going to bug me. It's 1. All right, so y is equal to 1. I got x is equal to negative 1, and I got x is equal to 1. I also have this little turning spot right here. We'll talk about in a second. So intervals. Now, this first one right here is increasing. So it's going up. So I'm going to start with my increasing. I'm going to do all my increasing. So this one's going from negative infinity. Let me do it in a different color. Do this one in orange. Increasing. So it's going from negative infinity all the way to negative 1. Because this piece right here, negative infinity to negative 1 is increasing. Now, from here to here, it's going up as well. And then it turns and goes down. So it's also increasing from negative 1 to 0. Then if I look at my other piece, now it's going to turn, it's going to decrease. And this is also decreasing. So looking at kind of your pictures here. So the other part's going to be decreasing from 0 to, that's a positive 1. And then it's got the asymptotes, so it's going to pick back up and go from 1 to infinity. Just kind of reading the different pieces of the graph. You see the middle, it turns. It goes from increasing to decreasing because that's a parabola piece. And you're good to go. Now, my end behavior, nice and easy. You're going ahead and listing it. So as x approaches negative infinity, my f of x is going to approach my vertical asymptote, which is 1. And then as x approaches positive infinity, my function is going to approach my vertical asymptote, which is 1. That's all we got. All right, take a second. I'm going to pause this so it's not super long online. Try number 3. All right, so let's take a look at this. So I went ahead and labeled everything while y'all were working. I got my horizontal asymptotes at y equals 0, vertical asymptotes at x equals -2 and +2, and I also have a hole here at -5. So my interval's here. So this first piece right here, if we're looking at it, this first piece is decreasing this whole time, right? So I'm going to go ahead and write that part down. Decreasing. And we're going from negative infinity, and it's going to stop at -2. Then I'm going to come over here, look in the middle again. This piece right here, it's decreasing this entire middle time. Still decreasing, right? It never turns and goes up. I could start with my pencil, and as I'm dragging, I'm still going down constantly the entire time. So that's going to be from -2 to +2. I don't know why I wrote infinity. And then I got another asymptote, so I got to stop it. Let's look at the last piece. It's starting up here, and it's decreasing forever and ever, even if it approaches the asymptote. So that's going from, what do we call it? That's +2 to infinity. Now, the only thing I forgot to add that I skipped right over was this whole, right? So in order to add the whole, you can do a couple things. One, I can come up here and say x cannot equal -5, or I can continue with the intervals and say -infinity to, where's my eraser? To -5, and then I add in -5 to -2. So this could go there if I'm going in order, but order doesn't really matter. So I really have 4 different pieces. I have my first part going from the forever over here to my whole to the asymptote, asymptote to asymptote, and then asymptote to end behavior. No increasing at all here. If it helps you to put that down, you're okay. You can put increase, none, or no increasing. And then my end behavior is the same thing. So as x approaches -infinity, my function is going to approach the horizontal asymptote, which is 0. And then as x approaches +infinity, my function is going to approach my horizontal asymptote, which is 0 as well. Just kind of taking a look at a couple different analyzing things, and we're good to go. So we talked about all the characteristics last week, how to get a graph. Today's just reading it and analyzing it, and we're done. Now, a couple things moving forward. Since this is the last kind of real class we will have, if you have questions, every Friday I'm on the first 20 minutes of class. If you have questions, you can ask. But moving forward,